Hello everyone. Let's move on to the questions about the hydrants table, which is part of the worksheet database. The hydrants table gives us information about various fire hydrants. You have columns like year, color, style, owner, etc. I've written down the row indices corresponding to each row in the hydrants table. Let's try to answer question number 8 here. Question number 8 says select color comma year from hydrants where color equal to blue. Clearly we are interested in the last 3 rows here and we want the color and the year column. So I'm going to write down color and year. Corresponding row index value would be 3, 4 and 5. And the value for the color column itself will be blue, blue and blue, sort of redundant. And for the year it's going to be 2010, 2014 and 2018. Right, before we move on to problem number 9, I want you to pause the lecture video here and look at how problem 8 and 9 are similar. You will find that problem 8 and 9 have the exact same answer. So let's quickly go through problem number 9 over here. Problem number 9 is executing the query select color comma year from hydrants, which correspond to the color and the year column, and we are capturing the result into a variable called df. So df is simply going to have two columns which are color and year, and the row index is going to be 0, 1 and etc. and the corresponding values are going to be red, red and so on, and year is going to be 1999, 2000 and so on. What are we doing with this particular data frame? We are applying the Boolean condition of df.color equal to blue. So for that particular condition you are going to get a Boolean series which contains false, 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 true, 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 and when you apply df of b in this format, you are going to get subset of the data frame which satisfies that particular Boolean series. So you are going to get the exact same output as the previous question over here. Alright, so let's talk about what sort of performance implication both of these variations have. So let me give you a concrete setup here. Let's say that you have a million rows in your hydrant table. So I'm going to write that down. You have 1 million rows. Given this additional information, I want you to think about whether the query in question number 8 would be faster or the query and the data frame lookup in question number 9 would be faster for a hydrants table which contains million rows. Go ahead and pause the lecture video here and write a comment in the comment section stating which question's solution would be faster and why do you think that will be faster. If you were thinking query in question 8 would be faster, you got the correct answer to my question. Why exactly is this the case? Let's think about it. So in question number 8, we are running the query where we have a specific condition set, and this select query is being run against the original table's data. So you are only going to create a data frame which has a size of 3 rows, correct? Data frame creation only for size of 3 rows. Okay, That's the first reason. The second reason is that databases are designed with performance considerations. So database performs very fast when it comes to executing a query on a table which contains million rows. So databases perform very fast in general. So let's think about why this first query in problem number 9 is much slower over here. That's because we are creating a data frame which has million rows, correct? It creates a data frame that contains million rows. That's going to take quite a number of time. Similarly, when you want to apply this data frame lookup operation, that's also going to be really slow for 1 million rows. So whenever you have a really large data, the recommendation is that you use SQL query on the database rather than trying to generate an intermediate data frame version. Let's go through query number 10 here, question number 10, sorry. It says select year from hydrants where owner equal to private and active. So we have a where clause which has a two-part condition separated by an and. The first part says owner equal to private, so that's going to be the owner column. The next part just says active. That's because the active column has a value of 0 or 1, right? So we are interested in the rows where owner is private and active is 1. There is only one such row in the table. So this particular query is going to have a result of year column corresponding to that row, and the index for the row is 2, and the year itself is going to be 2001 over here. Let's go through, need to do a little bit of damage control over here. Excuse me just for a second. Okay, can finish writing performance. Alright, sorry about that, my apologies. Let's go through last question in this page, which is question number 11. Question number 11 says select year style active from hydrants. So I am not going to write down each part of this problem because we are creating a data frame and then we are applying a boolean expression and then we are trying to get a final data frame out of this whole operation. So we are interested in selecting year. I am marking it up on the table, and then we are interested in selecting the style, and we are also interested in selecting the active. So what we are going to get out of step number 1 is we are going to get a data frame containing just those column values, and then we are going to apply this boolean expression which says df.active equal to 1. That's just going to be the last 4 rows over here, right? So what you are going to have is you are going to have df of b. So when you apply the boolean series back to the data frame, you are going to get a subset of the data frame containing all the column values for those 4 rows. But we are only interested in the style columns value. So what we are going to get here is you are going to get the style column corresponding to the row index values of 2, 3, 4 and 5. Looks like all of those style columns have the exact same value of baser. let's move on to the last and final page of this particular worksheet. For problem number 12, I am going to introduce you to a new function which you can use on pandas series. What I want you to do is, after I go through this particular problem on the worksheet, I want all of you to go back and go through this example using Jupyter Notebook so that you feel comfortable using the value underscore counts function. First of all, hydrants of color is going to give us a column series. That's because we are using the format df of some column name, so that's going to give us the color columns value. So you can call the value underscore counts function on any series. What it does is, it's going to count the unique values in the series, and it's going to take those values and it's going to, it's not going to count the unique values, it's going to take the unique values in the series and it's going to count the number of occurrences of each of those unique values. So since we have three different colors over here, which is red, green and blue, your first entry in your output series is going to be for blue. That's because that has the highest number of count, and the corresponding count is going to be 3, and the next count is going to be 2 for red, and then finally you are going to have green for 1, and this is going to be a series. So this particular operation outputs a series for you, and that's going to be a pandas series. Do these counts look very familiar to you? That's because this sort of corresponds to a dictionary that you might be able to generate if you were to iterate over individual values of that particular column for the color, correct? So if you want to convert this series into a dictionary, the syntax for that is very simple. You can simply say dict of in front of this operation. What it's going to do is, it's going to take this series and it's going to convert that into a dictionary. So you're going to get 3 key value pairs of blue 3, red 2 and green 1. So pretty much value underscore counts works on any series and returns a count series make sure that you are getting enough practice in terms of applying the dict conversion function between a series and a dictionary. Also try out the list conversion function. For example, when you say list of this particular series, what you are going to get is, you are going to get just the corresponding values. So if you say list of this series, you are going to get just 3, 2 and 1 over here. Make sure to familiarize yourself with both of those conversion functions and also explore the value underscore counts function so that you are able to understand it clearly. Right, let's move on to question number 13. Question number 13 applies a count aggregate function. So we are saying select color comma count star from hydrants where active is 1. So once again you are interested in last 4 rows, and then you are saying group by color. So we have 2 different colors which are green and blue. Interesting thing is, this query doesn't contain an order by clause. So the output of this query is going to be unpredictable. That's because your database rows can be ordered differently for the purpose of performance of indexing. So whenever you want to ensure that you're getting the correct ordering, you need to always explicitly use the order by clause. So one possible outcome of this query is going to be blue as the row index and the corresponding, actually not row index, sorry, color columns value, and the corresponding count star column is going to be, let me see, 3, correct? And when you have, sorry, my bad, I keep touching this with my wrist. I'm going to try and move this to up here, right? So for the blue color, you're going to get count as 3. That's because we only have last 4 rows. And for the green color, your count is going to be 1, and you'll get new row index values over here. You need to be really careful about this. This order is not guaranteed. You might get green of 1 as the first row and blue of 3 as the second row. Right, let's go through the next question over here. Select color comma count star as count from hydrants, group by color having count greater than 1. So you are going to be applying an additional condition, but to individual groups, correct? So the condition here is that the count should be greater than 1, and you're going to have 3 different groups when you initially start, right? So you're going to have the red group and the green group and the blue group. That's because we are grouping by color, but only 2 of those satisfy the group condition, which says having count greater than 1. Those 2 are blue and the red group. So what you're going to get here is again a random ordering because you didn't use the order by. So you're going to get color and count. So one possible ordering of that would be blue and 3, red and 2, and you'll get new row index values of 0 and 1. The last question for today's lecture, this is going to be select color comma count star as count from hydrants where year is greater than or equal to 2000. Recall that the where condition is applied to the original table, and then you're grouping by color, and then you're applying a sub condition for each group where count is less than 2. So first of all, you need to filter just the rows where year is greater than or equal to 2000. So that's going to be this row over here and anything which follows after that. So that's going to be row number 1 and anything after that. Right. So in that, what do we want to do? We want to group by color. Then we want to check that each of those groups have count less than 2. So you have 3 colors, red, green and blue over here. So that's going to be red, green and blue for this particular question, and only 2 of those have count of less than 2, correct? Blue color has count of 3, whereas green and red have count of 1. So your final data frame is going to contain the column of color and count. We name the column as count using AS keyword here. So the corresponding row index is going to be 0 and 1. For color red, your count is 1. For color green, your count is 1. Right, that will be it for today's lecture. Make sure to get more practice with quiz 11. We have similar questions in quiz 11.